All right, so apparently the video for 1A.3 did not save correctly, so we're going to do a quick little video to make up for it. So here we go. Starting off here, we talked about linear functions. We were reminding ourselves that when we are referring to average rate of change, and you're talking about linear function, it is the slope of the line, right? So it's going to be the slope of the line. When you have the equation of a line, that's our y equals mx plus b. That's a weird b. We're going to draw it in there. Okay. And so y is interchangeable with f of x. Our point slope form. Our point slope means that you've been getting a slope and a point. So the point we usually use is x1 comma y1. And you want to make sure these are user-friendly numbers. So I wouldn't choose like the largest number possible, but so you have y equals m times x minus x1 plus y1. We're going to just go ahead and go straight to this form instead of the traditional algebra 1 because therefore y is already isolated and we're ready to go. Okay. So for example, here we have this table, and on the table it says prove or determine if this is not a function. To determine if it's a function, linear functions have to have a constant rate of change. So we need a constant rate of change. So you're going to look at from numbers to numbers. So how does it change from here, here to here, here to here? So finding the rate of change between the numbers, they have to be the same. If they're not the same, then it's not a constant rate of change. So we're going to start off with 7 minus 4 over 2 minus 1. So we have 7 minus 4. That's going to give us 3. We have 10 minus 7. That gives us 3. We have 13 minus 10, and that's going to give us 3. Okay, now we're going to do our change in our y. Our change in our x's. 2 minus 1 is 1. 4 minus 2 is 2. 8 minus 4 is 4. So when we're looking for the change in y over change in x, so for our first two numbers, that's 3 over 1, right? Our next numbers are 3 over 2. Next numbers are 3 over 4. Because these are not equal, it's not linear because there's no constant rate of change. And that's why. So constant rate of change, no, there isn't one. All right. Your average rate of change in linear functions, the average rate of change, again, has to be constant when it's linear. And then the distance between the change between your average rate of change has to be 0. That's how you know it's a linear function. So back in Algebra 2, we talked about first difference, second difference, and things like that. Now we're focusing on average rate of change, okay? So we're going to start here. So on the interval from -2 to -1, we're going to find its average rate of change. So the change in my range, so -5 minus -7, that's going to put us at 2. Our change here, -1 minus -2, is going to put us at 1. So my average rate of change is 2 over 1, which equals 2. That's a weird equal sign. Okay. Then we're going to do from -1 to 0. So again, the change here, that's 2. The change here is 1. So we have 2 over 1, which equals 2. The change here, 2. Change here, 1. 2 over 1 equals 2. Change here is another 2. Change here is 1. So 2 over 1 equals 2. Now, what is the change in your average rate of change? The change in your average rate of change is saying, how did these numbers go? The change is plus 0, plus 0, plus 0. So it is 0. So when the change in your average rate of change, so I'm going to write that as delta A rock equals 0. That means you have a linear model. Okay. All right. Now, the average rate of change in the secant line. A blank is a line joining 2 points of function. That is a secant line. So I'm going to try. A secant line is a line joining 2 points on a function. Okay. You're going to find in the slope of the secant line through 2 points. So you have P A of f of A and Q B f of B. These are our 2 points right here. You will give you the average rate of change over the interval from A to B. So you're finding from A to B, okay? So this one is at A, this one's at B. Your intervals define your x's, okay? And so average rate of change, again, is just changing y over changing x, which is m secant. So when we write m secant, that means that we're not talking about a linear line, a linear function. We're talking about a line that's connecting 2 points on any function, okay? And it's the same thing, f of b minus f of a over b minus a. So again, see y2 minus y1 over x2 minus x1. All right. When you're finding the average rate of change, you need to make sure that it's over consecutive equal length input, okay? And then the rate of change, if it's consecutive equal length inputs and values, you can find a linear function, and then the rate of change of a quadratic function is going to be constant, okay? By a linear function, okay. And then here, it's going to be a constant. So now we're going to talk about quadratic functions, and their rate of change is going to be constant, okay? So remember I told you when I say the change of the average rate of change, I'm going to write delta A rock. So for quadratic, delta A rock is going to be constant, meaning that it's going to be the same, okay? So let's look at example number 3. So example number 3, we're looking at the quadratic parent function g of x equals x squared, okay? G of x equals x squared. So we're going to fill in the table with that function. Remember, this is x squared, so the values are being squared. So -3 squared is 9. -1 squared is 1. 1 squared is 1. 3 squared is 9. 5 squared is 25. Okay. Now we're going to find the average rate of change over this interval. Okay. So back in Algebra 2, you would do second difference. But in order for second difference to work, your values, you'd have to subtract again, and if it's all the same on the second difference. This time we're doing average rate of change, and we're trying to see how that's behaving. So you're going to find your difference. So change in my output, I am 1 minus 9 is -8. 1 minus 1 is 0. 9 minus 1 is 8. 25 minus 9 is 17. -1 minus -3 is going to be 2. 1 minus -1 is 2. 3 minus 1 is 2. And 5 minus 3 is 2. So now I'm going to look at my average rate of change. So from -3 to -1, that's going to be -8 divided by 2, right? -8 divided by 2 equals -4, okay? Then we have 0 divided by 2, and that's going to equal 0. Then we have 8 divided by 2, and that's going to equal 4. And then we have, guys, I wrote 17 and not 16, and no one stopped me. There's no way to stop me. And then we have 16 divided by 2, okay? And that's going to equal 8. Now, you're looking at the difference of your average rate of change. So from -4 to 0, that's +4. From 0 to 4, that's +4. From 4 to 8, that's +4. So notice that your average rate of change are constant, and because your average rate of change are constant, this is a quadratic. So what do you notice? It is your change in your AROC is constant, and therefore this is a quadratic model. Okay? All right, so on to the next. So the last part of the notes is the you do. So you're going to pause and you're going to test it out yourself to see if what you're given is a linear or a quadratic model. So pause and then come back. Okay, well, welcome back. So now that we're back, we're going to look at it. So again, from your intervals, so you found your change over the intervals. So 3 minus 11, that would put you at -8. -1 minus 3, that would have put you at -4. -1 minus -1 would have put you at 0. And 3 minus -1 would have put you at 4. On this side, we have -1 minus -2, which puts you at 1. 0 minus -1 puts you at 1. 1, 1. So now you're finding the slope. Thankfully, it's all ones. Look how nice I am. So you have 8, -8, -4, 0, and 4. The change from here to here. So this is +4, +4, +4. So what is the change in your A-rock? So your change in your A-rock, they are all equal to 4. And because they all are equal to the same thing, that means that this is a quadratic model. Hopefully you got that. If you did, congratulations, you're a genius. Okay, so we're going to go back to Algebra 2. So in Algebra 2, we learned that average rate of change. In Algebra 2, we determined whether something was linear, quadratic, cubic, quartic, or exponential using knowledge of the following part. You would find a common difference, right? So you remember linear, if the first difference, quadratic was the second difference, or it was neither, and exponential was if it was multiplication, right? So when we are looking here, going back over that, this is just subtraction. You want to make sure that they are equally spaced apart and go from there. So when I have 1, 2, 3, 4, cool, I can go from there. You could go through that, right? But however, this isn't equally spaced apart, which is where the average rate of change comes into handy, okay? So average rate of change is more effective because they don't have to necessarily be in consecutive order. We can just focus on the average rate of change and then compare and see what they look like. And if it's equal to 0, then great. The change in your average change is equal to 0, then it's a linear. If it's a change in your, if it's constant, then it's quadratic. So we don't have to worry about first and second difference anymore. We're going to just strictly focus on how is your average rate of change going, okay? So on these problems, that's what you should have done. You're going to go through and you're going to sort from there, okay? Okay, so if you look right here on the first table, because these are equal length input values, the distance between are equal, I can go back to our Algebra 2 method of finding if using first and second difference. So notice that the first difference here is not the same, but the second difference is the same. Okay, now this wouldn't work for that because if you look at your input value intervals, they're not equal distance. So this one is a +1, this one is a +3, this one is a +5. Okay, so now that's why this is when you would use your average rate of change. So from 1 to 0 is 1, 3, and then we have our 5, right? So now we're going to compare how did the average rate of changes come. I'm going to do it over here because I don't have any room. So I'm going to do my change in my y over my change in my x for these. So we have 1 over 1, which is 1. We have 3 over 3, which is 1. We have 5 over 5, which is 1. Since these are equal, right? Therefore, I know that this is linear, okay? And my pen is writing really weird, but we also know that the change from here to here is 0, which is why it's linear, okay? So this would be, so we had a quad, we had a linear, and then this one again, not equal distance. Well, they are equal distance. We have 2, 2, 2, okay? So they're equal distance. So at this point, you can choose, how do I want to do it? Do I want to do average rate of change or do I want to do linear? So let's look. 1 minus 1 is going to give me 1 minus -1 is going to give me 2. And then we have 2 minus 1 gives me 1. 2 minus 2 gives me 0. So the average rate of change here. So the change in the y over the change in the x, that's going to give us 1. So our first one is 1. And then we have 1/2. And then we have 0. Not the same. So they're not the same, so it's not linear. So then we're going to look at its difference. So -1/2, -1/2. So the change in the A rock are the same, they're constant. And because that, therefore, this is a quadratic. Okay, so hopefully you came to that conclusion. At the end, the 3 things that you need to walk away from this lesson is understanding that over any length input value interval, okay, any length, so no matter how spaced they are, if the average rate of change for a linear function is going to be constant, it's going to always be constant, which would be if you look at this guy. Okay, next, given consecutive equal inputs. So if I have consecutive equal inputs, then I can use the algebra 2 method of finding the second difference. Okay. But if not, notice here, this is your inputs. I can do that. Or when it's not, I would use this method to find the distance. Not the distance. I don't know what I'm talking about now at this point. The average rate of change of a quadratic function, okay? And it can be represented, the change can be represented by a linear function, and that's because it's a constant. And then the average rate of change over the closed interval from A to B, we call that the slope of the secant line, okay? So that's our MSEC, our slope of our secant, okay? And that is the lesson. That was kind of fast and jumbled. Hopefully